Hi, today, uh, Unit 1, Lecture 2. The topic is stress and strain diagram, stress strain diagram for mild steel rod, and types of stresses and types of strains. What is stress and strain diagram? Stress strain curve is a behavior of material when it is subjected to load. The relation between the stress and strain that a particular material displays is known as stress strain diagram. So in this diagram, we plot strain in x direction and stress in y direction. The stress strain curve for different material is different. It may vary due to the temperature and loading condition of the material. Stress strain diagram for mild steel rod. Generally, mild steel rods are highly prepared for many construction purposes as it has high tensile strength when used with the concrete. So knowing the behavior of the mild steel rod under loading helps in choosing for the better rod. The behavior of the mild steel rod under loading can be analyzed using the stress strain curve for mild steel rod. The stress strain curve consists of various stages. They are proportional limit, elastic limit, upper yield point, lower yield point, ultimate stress, and breaking stress. So you can see this is the stress strain diagram for a mild steel rod. So when you conduct the test in the by using the universal testing machine, so when you are applying the load on the mild steel rod, it means tensile load. So when you apply the tensile load on the mild steel rod, the stress is increased. So due to this stress, the strain also increased parallelly. So at point A, this point A is called the proportional limit. So at this point, the stress is directly proportional to the strain. It means the material, the mild steel rod obeys the Hooke's law. So if you remove the load, the material comes to its original position. So at point B, so you can see this is the point B. So this is a elastic limit. So when you are keep on increasing the stress, the strain also parallelly increase. So at point B also the material obeys Hooke's law. It means if you remove the stress, the material comes to its original position. But beyond the B, the material don't have the elastic limit. So it is the maximum limit at which the material comes to its original position, that is called the elastic limit. So beyond this point B, if you increase the stress, what will happen? The material starts yielding. It means the material subjected to deformation. So it means the material will not obey Hooke's law. It means the material will not come to its original position even if you remove the load. So this zone is called the point C to D. This is zone is called yielding zone, yield point. So in this yield point, the point C is called upper yield point and point D is called lower yield point. It means upper yield point means the maximum stress required to produce yielding or a deformation. Point D, lower yield point means the minimum stress required to produce the yielding or deformation. So if you beyond the D point, if you keep on increasing the stress, it reach the point capital E. So in this point, the material will get the maximum stress. It means after this point, the material will not withstand its strength. It means it can fail you, right? So at this point, E point is called the ultimate stress or ultimate strength. So beyond this point E, if you apply the load, the rod will break. So this point, F point, the rod will be breaking. It means the rod will be failure. This point is called F point. So this is the stress strain diagram for a mild steel rod. Okay, so that's the curve obtained is the stress strain curve. The point A to B The point A to B is the elastic region and the point B to F is the plastic region of the mild steel rod. Similarly, if you plot the stress strain curve for any other material also, we can able to determine the yield strength, ultimate strength and breaking point of any type of material. This is the stress strain curve for mild steel rod. Now we can see the types of stresses and strains. The types of stresses are compressive stress, tensile stress, shear stress. And the types of strain are compressive strain, tensile strain, volumetric strain, and shear strain. So now we can see what is compressive stress. The stress induced in your body when subjected to two equal and opposite pushes. So if you apply the pushes, as a result of which there is a decrease in length of the body is known as the compressive stress. So the compressive stress act normal to the area and it pushes on the area. So the length of the bar will be decreased. And we can see what is tensile stress. The stress induced in your body when it is subjected to two equal and opposite pulling force. Because of the two equal and opposite pulling forces, the tensile stress will be developed. So as a result of which there is an increase in length of the body is called tensile stress. The tensile stress acts normal to the area and it pulls an area. Now you can see the shear stress. The stress induced in your body when subjected to two equal and opposite forces which are acting tangentially across the resisting section, as a result of which the body tends to shear off across the section is known as shear stress. So instead of the normal force, there will be the parallel force. So when the force acting parallel to the surface of the plane, then there will be the shear of action will take place. The force because of the stress, that is called the shear stress. The shear stress is equal to force divided by area. So the shear stress acts tangential to the area. So the difference between the normal stress and shear stress is the normal stress means the load is acting perpendicular to the plane of the section. Then the stress developed is called normal stress. So instead of the perpendicular load to the plane, parallel load, if the load is acting parallel to the surface of the plane, then there will be a shear stress will be developed. So compressive strain, the ratio of decrease in length to the original length is known as the compressive strain. So you know what is strain? Generally the strain is nothing but the change in dimension divided by original dimension. So the ratio of the decrease in length, because of the compressive stress, the length of the body gets decreased. Therefore the ratio of the decrease in length to the original length is known as the compressive strain. Then tensile strain. The ratio of the increase in length to the original length is known as the tensile strain. So because of the pulling force, there will be the increase in length. So change in dimension by original dimension. If the increase in dimension, then it is called tensile strain. Then volumetric strain. The ratio of change in volume of the body to the original volume is known as the volumetric strain. Shear strain. The strain produced by the shear stress is known as shear strain. It is nothing but the transverse displacement divided by distance. So, thank you for listening.